Hi, I'm Talina Edwards. I'm an architect and certified passive house designer, and today I'm also joined by Stuart Lee, a builder, and the homeowner, David Ryan, to share the story of Our Woods Passive House from our three perspectives, including lessons from the design stage, during construction, and post-occupancy insights. There's always a hidden owl in knowledge. So one of the things we love most about the Passive House community is the generous sharing of knowledge. Once you know Passive House, you can't unknow it. And Passive House people are pretty passionate for good reason. We'll be sharing the story of this project. The brief was for a sustainable tree change home. And during the design process, it evolved from simply being a solar passive home to be aiming for certified Passive House standard. It was completed in 2019 when we achieved our certified Passive House status. And it has become a well-known case study in the community and winner of some design awards as well. And this is our entry on the Passive House database if you want to look it up and find out a bit more about the specs. We were told it was a project that raised the bar for what was achievable in sustainable architecture and home building. And our aim is really to inspire others to achieve this as well, because if we can do it, you can too. And we love this quote about wisdom must be the intuitive reason combined with scientific knowledge. For me, that's what architecture is all about, the combination of that creativity side and the science. And it's time that as designers, we really understood the building physics more. So I run a small architectural practice in Ballarat in regional Victoria. All of our projects are sustainable homes and almost all of them are currently aiming for certified Passive House. So here's some lessons we've learnt along the way. Firstly, don't be afraid to push the envelope in more ways than one. So with the Our Woods house, it's in Trentham in regional Victoria, which is 700 metres above sea level. So the temperatures there do get below zero in winter with occasional snow, ranging up to 40 degrees every summer. We also had a BAL, a bushfire attack level of 29 due to the woods that were to the south. And then the corner site did have some site constraints of itself, with north being across to the side there. The site was really orientated more to the west than the north, so we did have to push the envelope with how we could try and orientate the house to the north, but it ended up a little bit closer to the west. So we dealt with that in terms of our shading and optimising the solar gain in winter, but ensuring that we had adequate shading in summer and other times of the year as well. So it's a pavilion style home. The house is broken into the three parts, so the living in the middle, bedroom wings to the side, which allows for these outdoor spaces to connect to the garden. So the shading, as you can see here, is fixed at the top with our eaves, as well as these fins that are angled on the side that are really helpful for the lower afternoon sun. And there's also operable external blinds. Passive House pros did laugh at us for the form factor on this project. And there is a reason why most certified passive houses are simple boxes. It's all about the ratio of external wall area compared to floor. So because our form factor was high, it meant we needed higher insulation and higher performing windows, triple glazing. But what it meant was we could still achieve Passive House without compromising the original design. And we certainly learnt the limits of solar passive design and pushed the boundaries of our own understanding about that. So we came from the old school thinking of mass and glass is what's important, but realised that it's more about that air tightness and the insulation. We absolutely learnt the importance of windows, as they are the weakest link in the building envelope and the biggest expense. So it's so important to get them right. These were aluminium clad timber, triple glazing imported from Europe. And we learnt about the balance of making sure we had enough glazing to get in the solar gain and the sun when we wanted it, but not too much glazing where it would really lose too much heat from the building overnight in winter. We also had the balance of fixed windows as opposed to the openable ones, with strategic placement to allow plenty of cross-flow ventilation and night purge with our tilt and turn windows, but also having fixed windows where it was more cost effective to do so. We learnt to love data and graphs. The PHPP is our new friend because there's so much helpful information, and we learnt we can use it as a design tool. So we have become quite inspired by the data and the numbers. Our next lesson is all for one and one for all. We absolutely learnt that the collaboration and co-creation with our clients, our builder, and our consultants was the most rewarding part of the whole project. We shared a common goal, and it was great to work towards that together. We always had clear communication with all parties, and we realised too that Certified Passive House is a steep learning curve, but you don't have to do it alone. So you really do benefit from having the right team on board. We had a Certified Passive House consultant help us out during this project, and we learned all about the performance gap. The star rating, the predicted performance, really does not correlate to the actual performance, which is why we've loved what Passive House and the Passive House planning package has taught us. We learnt to speak a new language and loved what we learnt. All of the new building science lingo, what a U value was compared to what an R value was. And these are the numbers for the roof, wall, floor, and the windows for this project. And so much so that both myself and my colleague Mia went and undertook our Passive House training to become Certified Passive House designers as well during the process of while this was under construction. So Luke helped us out with the PHPP for this project, but now we're learning how to drive it ourselves too. We learnt so much about loving our Passive House community. The shared knowledge, the kindred spirits all wanting to build a better future is really amazing, as I'm sure most of you would know. And another important thing we learnt was that there's no such thing about attempting Passive House principles. It's really tricky to try and achieve an almost passive house, because if you're not all in, there really can be undesirable consequences, and that's not what we want. My last lesson is about the quest for the silver bullet. Is Passive House the answer? Well, we love Passive House because it's comfortable, healthy, has low energy use, and can have really quiet and resilient homes. But that's kind of where it stops in terms of the criteria as a standard. We like to take a holistic approach and go a step further, really embracing biophilic design and our connection with nature, looking at water use, all electric home, looking at the embodied energy and where materials are sourced locally or recyclable wherever possible, looking into the biodiversity of the whole site and landscaping, and also considering adaptable and flexible use of the spaces within the home so they can be not as big. So we love this graph that talks about where we're headed from a degenerative state to sustainability, which is where we're sort of sitting in the middle, and how we really need to go beyond sustainable, which is really just about doing less bad, and move towards regenerative development and doing more good. So we love that Passive House really does mean that we can achieve that net zero carbon, deal with the health side of things, and it's a really good stepping block to then move on and start to look at how we can even do better. And finally, we learnt more about caring, because Mother Earth actually doesn't need saving. She'll survive even if humanity doesn't. But the Passive House community shares something in common. We do all care, and we care about our future, and we know that Passive House is a way that we can do better. So thank you, and I'll hand it over to Stu and then David.
Hi everyone, Stuart Lee here from Craftsman Quality Builders. That's me on the left there, a few years younger and looking quite happy, which is great, which is normally how we operate on our job sites. How much fun can we have today? That's my motto, and all the boys that work together have the same attitude, which is fantastic. This is my little take on the Our Woods Passive House. It was a really great project to be involved with, and these are a few of the things that we experienced along the way. So no problems, only solutions. That's how I like to operate. We'll always come up against interesting things along the way, and it's just a matter of what we need to do to try and solve them. So here we've got just another slide of the build, which is, you know, really beautiful design by Talina and the team. And it's, yeah, what to do when problems arise, not if they arise. So, you know, the importance, as I mentioned just then, having a really fantastic team who are happy to work together in trying to solve the issues that may arise. You know, it's better to have 3 heads, 2 heads than one, you know, so one person doesn't need to know everything. And when you can collaborate together with a great team, that's the best way to create a brilliant outcome. On the Passive House, Our Woods Passive House project, we had Talina and the team, which were absolutely fantastic, and also David and Yvonne, who were one of the best clients I've ever worked for. We're able to always sit down, discuss the things that needed to shift or change, and come up with a solution that suited everyone. So that's a really important thing that I've learned along the way, is to have a great form of communication with everyone. The greatest teacher, failure is, says Yoda. And that is an absolute like classic line. And it's not kicking yourself about making a mistake. It's like, oh shit, I'm not going to do that again. So one of the examples of that was here on the job. We I put all the insulation. I put the membrane under the floor first, put all the insulation in, and then we laid the floor, and I glued all the joins, and I felt that that was going to be sufficient to keep the water out. Not the case. Once it bucketed rain on this job, we happened to fill up the subfloor with water, which was fantastic. So I had to cut out all the membrane underneath and pull out the insulation that was still wet, and allow the rest to dry. And then, fortunately, like any more water that fell just came straight through, and then the insulation didn't absorb it. So there's a lot of different procedures I go about now when we build, and so, you know, the insulation is always kept dry. So that was one mistake that, you know, cost me a bit of money, but in the end, I'm certainly not going to do it again. And one thing about building a passive house as well is attention to detail. That's really important. And we're wanting to build a ventilated esky. Basically, that's in a nutshell with building a passive house. So as you can see, we've got super insulated subfloor, and, you know, we're building in transom, so we're about 700 meters above sea level, so it's quite cold. And the detail I mentioned is just on the left there, where the insulation in between the webs, you know, it's got to be fully insulated, and a continuous insulation layer. It's really, really important. You can have too much insulation, believe it or not. Depending on where the vapor membrane is, you don't want to have too much insulation on the warm side of your membrane. What that can do is cause water activity, i.e. condensation, and that's really detrimental in a passive house, because that's something that is modeled to make sure that we don't get any condensation on the inside of the structure. And if you add too much insulation to the warm side of the membrane, so you've got insulation on the outside, which is the cold side, and then if you put any on the warm side, you need to do a thing which is called a WUFI analysis, a WUFI hygrothermal analysis, and that will detail where the condensation could be at risk. So in this next slide, we've got a typical detail of a wall detail provided by the architect, Talina in this case, and so on the right hand side is our outside, as you can see, and then we've got rigid foam insulation, and then airtight layer, which is our red line, and then we've got some acoustic bat insulation. Now that was just to just give our wall the maximum insulation that we could get, and also making sure that we didn't cause any critical issues with the WUFI analysis. And that was performed on this job to make sure that we weren't doing anything that wasn't kosher. Becoming an airtight ninja warrior. Now, whoever else is in the passive house space, which I dare say you would be if you're watching this, attention to detail, and if you make a hole, just tape it. As you can see here, the importance of taping. We've got all the windows fully taped, and you can see on the right hand side we've got even some of the tape, some of the staples and everything like that have been taped, just because it's really critical to make sure that we don't have any holes. You know, the more that you can find and tape up, and the better the outcome you're going to have in the once you do the blower door test, which you'll see later. Now, in this particular project, the air tightness had to go underneath the ceiling and then continue it out to the outside of the stud. Now, one of the beauties about having the air tightness layer on the outside of this frame is that the whole internal frame is left open for services. So here you can see, you know, the pipes and electrical and everything like that are all clear and easy to run. On different forms of a construction, you know, you have service cavities, and that makes it easier to run as well. But also down here, we've got the penetrations coming through the airtight envelope, which is the flooring in this instance with the waste. And as you can see, that's all taped and sealed, and make sure that's really airtight, which is, once again, a really important feature in a passive house. Now, part of being really efficient at air tightness, it's also keeping everyone educated who comes on site. We work with the plasterers, with the plumbers, the electricians and everything like that, just to make sure that everyone knows what that white paper is, and to be really mindful of it. And if you make a hole, let us know, we can tape it up. It's not that hard. And so we have checklists on site, and the whiteboard here, which just talks about making sure that everyone that's working there is aware of the things that are coming up, and to make sure that nothing gets missed, because you don't want to get to a position where you've forgotten something and then too late, she cried, and that's a big expense to try and rectify. So the more systems and processes you can put in place along the build process, the better the outcome will be. Now, when we've started this process, I didn't know much about windows and doors coming in from Europe, and now, you know, quite experienced at it, which is great. Some things to be aware of, I suppose, is your door openings. Even though you might have an 1100 hole, say, in your framework, once you open that door, because of the thickness of the frame, you end up with only like a 900 sort of walk-through section. So it's really interesting to sort of get your head around what that actually means in real world terms when it comes to ordering windows and doors. And if you've got a good window supplier and everything to work with, they often can help you along the way, making sure that those decisions are correct for your build. The other thing to note there is on the left, you can see that the reveal comes out from where the hinges are on the door frame. So therefore, you know, you do have some restrictions around how far the door can open, depending on where it is situated within that wall frame. Now, another part of passive house, which everyone should know, is mechanical ventilation. This job was really interesting, where we did a piggyback system with an AC. Fantech have designed this system to work with the Zender HRV system, which we used. Now, one of the limitations, I suppose, we had with this job was space. So putting the AC unit and the ducting all outside the airtight envelope was the best situation. However, it did cause us some issues along the way, particularly with the AC unit. You know, they're not designed to be airtight, and once the ventilation system runs outside the airtight layer, it forms part of the airtight layer, which then means all the pipe work and everything has to be all taped and sealed to make sure that it is airtight. Now, a bulkhead AC unit isn't designed to be airtight, so that took a fair bit of work to get that right. This photo is as it's been installed, so it is all fully insulated. Just to note that that whole system is all within the insulation layer, therefore not getting heated up by any of the ambient air around it. So that's all insulated, and it performs really, really well. So critical part of the air tightness test is the blower door test. You need to be under 0.6 air changes. An air change is the total volume of air in the building leaving per hour. So that's an air change per hour. Now this is done under a pressure of 50 pascals, and that's equivalent to a 35-kilometre-hour wind on the building envelope. So it just wants to make sure that the house is performing under sort of extreme wind conditions, and 35 k's an hour isn't that extreme, but that's the sort of average that it's tested at. I like to perform the tests as often as required. So fortunately, I have my own blower door, and we do it definitely before plaster while the membrane's still exposed. And then I like to do it again after all the penetrations and everything have been done. They would have been done at this point as well. But if there's any other external penetrations that need to be done, we're going to make sure that is still tested, and we're going to get under 0.6. This job got under 0.6, so we're happy days.
Thanks, Stu. Based on Yvonne and I living in our passive house for 18 months, I'll share a sort of summary of benefits and drawbacks from that time. But first, the single most important aspect of living in a passive house for us is being an active owner. They say a passive house needs an active owner, and we have certainly found that, because of all the benefits of a passive house, you don't get it all for free. You know, a passive house is low energy, it's not no energy. It's about finding alternative sources of energy, understanding them and harnessing those alternative sources for the benefit of the house and the environment. We've all seen graphs like this in books and on sort of passive house sites, and to be honest, I didn't really think they were that realistic or realistically achievable without significant heating and cooling inputs. When we were building our house, the neighbours around us, they called us the idiots with no heating. But after 18 months, I can confidently say that they were wrong on both accounts. Firstly, we do have heating. We just have a lot less than everybody else does. And secondly, we're not idiots, because we now have our very own charts like these to tell the same story. So as Talina said, we live in regional Victoria. We're at a fairly decent altitude, so it gets quite cold. But because we're away from the coast, then we get some sort of fairly decent temperatures in the summer as well. So this is a chart of external temperatures over the 18 months or so from May last year. And you'll see that we range from sort of negative in the winter up to sort of 40 or so in the summer. And on average, that sort of sits around 5 or 6 degrees in the winter and just under 20 in the warmer months. If we layer on top of that what we're finding in the house for that whole time, and it sits at a really comfortable and nice 21 degrees the whole way through. So yeah, it works. Yeah, it does what it says on the tin. There's a couple of blips in here which I'll point out. Firstly, we were away for a couple of weeks in spring last year, and you set the house to away mode and it cools down gently, but then heats back up again when you're in it. The other spike was when we were really not understanding how the house worked particularly well, and I'll come on and explain that in a little bit more detail later. The same sort of thing applies for humidity. So this is a graph where the grey is the external humidity, so it's pretty high most of the time. In the summer, it bounces around from humid during the day to less humidity at night. And the house sits in a really comfortable range for humidity, sort of 45 to 50 or 60%. So great for comfort, but also great for inhibiting mold or these sorts of things. So how do we do this? Well, I think this is probably how my kids see me, being a bit of a geek. But really, you've got to be able to measure it to manage it. And certainly our experience is that I think to get the best from a passive house, you've really got to understand how the whole system works. That's the house and the environment. And also that your behavior needs to be an integral part of that system to maximize the benefit you get from a passive house. So the first sort of lesson that we learned was you've got to understand your energy usage and adjust it. So this is like a typical distribution of power usage that any house would see. In a passive house, it's just lower. You draw power in the morning and in the evenings, much more so in the winter for the red areas, and less so in the summer. We're an all-electric house. We've got low bills, but a passive house needs energy inputs into it. And ideally, you want to get those from alternative sources. So typically the sun, but also the body heat of occupants and activities such as cooking and showering, etc. And then the passive house is great at holding on to that heat. But you've got to be able to understand how to use them, and then it's supplemented by energy from the grid. So you need to use the tools you've got at your disposal. Your heat recovery system is great at holding on to the heat or holding on to the cool in the summer, but it doesn't generate it. It's a ventilation, it's not a heat source in itself, but it's great at retaining that heat. So you use it wisely. The next two things are, to me, the most critical. One is the weather, and it's understanding what's going to happen on the weather, not what has happened. So you need to understand, how does your house perform in the weather? So for example, we know that our house, when it's windy and below about 6 degrees, it loses a couple of degrees overnight. When there isn't much wind, then it holds on to that heat and hardly loses any. So you've really got to understand how your house performs in the weather, and also if you know it's going to be sunny the next day and you know you're going to get lots of solar gain, then you probably don't need any heat boost in the morning. You just wait for a couple of hours and the house will heat up through the sun coming in. So it's about using those alternative sources of energy and understanding how the house is going to behave when that alternative energy is available to you, and not just putting the thermostat on and getting, if it's not warm immediately, getting electricity to heat it up. Wait for the sun. So understanding how the house performs. The second one is allied to that, and that's understanding how shading and sun impact the house. So a key thing for us is that lots of light does not necessarily mean lots of solar gain. We made a mistake at the beginning thinking that we could obtain a little bit of extra privacy by having the blinds down but open, and then we were wondering why the house was colder than we wanted it to be. The key thing here is that the blinds, even with open, were cutting 30–40% of the solar input out of it. We really didn't realize this one. So the key thing with shading is make sure you understand how it works. So open it up when you need that sunlight coming in, close them down when you don't need the sunlight. So you're acting in effect as a thermostat around that side of things. Here we go back to that spike, which I said earlier, and this is sort of the perils of not really understanding how heating and shading will work. And this was an example of the owners underperforming rather than the house underperforming. But the first part of this graph is where I happened to be away on business, and Yvonne was getting used to how the house was working, and complained that it was really cold for a day or so. What had happened was, and this was in June, so it was in winter, if she'd gone to work and left the blinds closed, had come back and the house hadn't heated up at all. In fact, it had cooled down. So then we discussed about making sure the blinds were open to get the heat. So the next day she went away to work, left the blinds open, beautiful sunny June day. As she came back into the house, the dog bolted out of the house to get a drink because we had basically boiled the dog nearly for a day. It got up to 30 degrees in the house. So really got to understand the impact of shading and what the weather is going to be doing. Understanding the weather is going to be sunny for the rest of the day, therefore don't have the blinds all the way open. So, quick summary of the benefits and drawbacks. So these are the filters used in the HRV system. On the left-hand side is the external filter, so air coming in just prior to, or just being that changeover time, which is once every 6 months. The other one, the middle one, is the one on the internal side. So again, a bit of dust coming out of the house, and the right-hand side is the new one ready to go in. So a lot less dust in the house because of that filtering. We dry all of our clothes internally just by hoisting them up into the ceiling, and we get, there's a nice constant low humidity airflow going through the whole time, and everything's dry within 8 hours or so at the most, typically overnight. We do get condensation in the house, but it's all on the outside, and in the winter it freezes, which is fantastic. So you get frost on the outside of the windows. I have for many years lived in a house where we used to have frost on the inside of the windows. So living in a passive house is a fantastic benefit. Dissonance. This is a downside to me. You are out of touch with the environment outside in a passive house. Firstly, the temperature. So often you'll sort of look out the window and go, okay, that looks good outside, open the door and go, oh, that's cold. You just don't get that feeling inside. And secondly, with noise, because the house is well insulated, then it also cuts out some of the noise. So you're a bit disconnected with your environment. Okay, so here's a sort of summary of your passive house that we find it. Certainly, less energy use, great thermal comfort and control of humidity, no drafts, less dust. We dry our clothes nice and naturally. It's quiet, and the house just feels solid. On the drawbacks, our particular house is a Faraday cage. We have no mobile signals inside it, and that's nothing to do with a passive house. That's just construction, which has got foil-backed insulation and colour-bond cladding. And secondly, lots of people sticky beaking around the house because they like the look of it and they're interested. Both of those are drawbacks to me. The dissonance aspect, some people might see that as a benefit. I see that as a bit of a drawback, but something that I'm willing to accept based on the benefits of the house. And the need for active ownership, I see that as a massive benefit. I like to be involved, I like to understand what's going on. Other people might find that as a bit of a drawback. Okay, so just to wrap up, we are really proud of what's been achieved with this house. That the house and the design is admired, the thermal performance is marveled at by people, and the whole collaborative nature of the design and build process was absolutely fantastic. And that's why we are really proud of what's been achieved here. And because of that, we are happy and will continue to be advocates for generally better buildings, including passive house standards and generally ecological friendly buildings. It's become a very popular topic, and we've been involved in passive house days, sustainable house days, the Undercover Architect podcast, and then obviously what we're looking at today. And we'll continue to do that. But when we started on this journey, we just wanted to build an ecological friendly house. We really didn't know what that meant. And through a passive house, we are really happy to have done our little bit to improve things, by building the house and continuing to advocate for this type of building. But none of this would have been able to have been achieved without Talina and Stu and their teams. So thanks for your time. We hope that you've all learned something new about what it takes to design, build and live in a passive house.